Welcome to today's lesson. I'm Saka Clindenz, and so I'm going to take you through a lesson physics. Basically, we'll look at coefficient of friction. And so we go straight into the lesson. So those who want to contact me for one-on-one lessons, actually, you can use my WhatsApp number. Plus 260 977 419949. This is my WhatsApp number. You want lessons one-on-one and we can discuss. And so we have here a question. A book of mass 2.5 kilograms, which is mass 1, is placed on an inclined plane where it makes an angle of 30 degrees with the horizontal and is connected by a loop over a massless and frictionless pulley. The coefficient of kinetic friction at mass 1 is actually 0.3. The second book of mass 5, which is mass 2, is connected and it is hanging vertically as shown below. Consider the lobe to be massless also. So we are actually required to calculate the acceleration of the books as well as the tension on the lobe. And this is the configuration actually. Okay, so basically here we have our mass here, which is actually mass 1. And then here we have our pulley and our tension. This is actually mass 2, which is 5 kg, while mass 1 is actually 2.5 kgs. And this angle here is 30 degrees. So we are asked to calculate the acceleration of this. Well, the first thing is that we need to draw a free body diagram. We identify that actually the normal force which is perpendicular to the plane here is actually that one here, and then we have the weight, which is actually mg, and there is an extension to this one, another force which is equal to actually the normal force, which is mg cos theta, because this angle is also actually sin theta. And we can draw right angle triangle here, where this one is actually 90, and this is mg sin theta. And this is the same as this one, which is also mg sin theta, because they are actually parallel. So this side is equal to that one. And so we are taught actually the coefficient of kinetic friction is actually 0.3, meaning that there is actually friction in this direction. And therefore, this one will be our tension, and this one will be tension. And this does not extend, our log does not extend, meaning the tension here and here are the same. And therefore, we can say the normal force is equal to mg plus 1 cos 30. Cos 30. Okay. And we know that friction is equal to mu times coefficient of kinetic friction multiplied by the normal force. And therefore, our friction will be equal to coefficient of kinetic friction multiplied by the normal force, which is m1 plus 1 multiplied by gravitational field strength multiplied by cos theta. And therefore, we know that force is equal to mass 1 multiplied by acceleration. And therefore, we know that this object 1 will move upwards. It will be moving actually upwards, while this one will be moving down, because this is actually has a more mass than the one which is on an inclined plane. And therefore, we need to subtract the friction because it is opposing the motion, as well as the other force, which is mg1 multiplied by sine theta, which is equal to mass multiplied by acceleration. And therefore, we can make T the subject of the formula by saying mass 1 times acceleration plus friction plus mass 1 multiplied by gravitational field strength multiplied by sine theta. And therefore, we can say mass 1 times acceleration. And we found that our acceleration, our friction is actually coefficient of kinetic friction multiplied by mass 1 multiplied by gravitational field strength multiplied by cos theta. Okay. Multiplied by cos theta as our friction, then plus mass 1 multiplied by gravitational field difference multiplied by sine theta. And so this one becomes our tension. And this one becomes our equation number 1 for mass 1. We have merely subtracted the opposing forces, which is friction. This is the friction actually, which is moving in that direction. And also we have this one, which is also mg sine theta, which is moving in the opposite direction. And therefore, now we can look at mass 2. We know that here, mass 2 actually is moving down because it's greater. So the weight would be greater than the tension. And therefore, we can solve mass 2 multiplied by gravitational field strength minus T is equal to mass 2 times acceleration. And therefore, our tension will be equal to mass 2 multiplied by gravitational field strength minus mass 2 multiplied by acceleration as our equation number 2. And remember, we found another equation. For equation 1, we said tension is equal to mass 1 multiplied by acceleration plus coefficient of kinetic friction multiplied by mass 1 multiplied by gravitational field strength multiplied by cos theta plus mass 1 multiplied by gravitational field strength multiplied by sine theta, which we said this is our equation number 1. And therefore, we know that here T is equal to T from equation 1 and 2. And therefore, we can say that M1, we can equate the two plus coefficient of kinetic friction multiplied by mass 1 multiplied by gravitational field strength multiplied by cos theta plus mass 1 multiplied by gravitational field strength multiplied by sine theta should be equal to mass 2 multiplied by gravitational field strength minus mass 2 multiplied by acceleration. And therefore, we can group the right term together. So we can say mass 1 multiplied by acceleration plus mass 2 multiplied by acceleration. When I brought the acceleration this side, should be equal to actually mass 2 multiplied by gravitational field strength minus coefficient of kinetic friction multiplied by mass 1 multiplied by gravitational field strength multiplied by cos theta minus mass 1 multiplied by gravitational field strength multiplied by sine theta. We have now rearranged these two equations, and therefore we can factor out acceleration since it is actually common here. So we're going to have mass 1 plus mass 2 in brackets. It should be equal to mass 2 multiplied by gravitational field strength minus coefficient of kinetic friction multiplied by mass 1 multiplied by gravitational field strength multiplied by cos theta minus mass 1 multiplied by gravitational field strength multiplied by sine theta. And therefore, we can now make acceleration the subject of the formula by dividing both sides. So we're going to have m2g minus coefficient of kinetic friction multiplied by mass 1 multiplied by gravitational field strength multiplied by cos theta minus mass 1 multiplied by gravitational field strength multiplied by sine theta. Then you can divide by mass 1 plus mass 2. And therefore now we can substitute the figures. And so we said acceleration is equal to mass 2 multiplied by gravitational field strength, coefficient of kinetic friction multiplied by mass 1 multiplied by cos theta minus mass 1 multiplied by gravitational field strength multiplied by sine theta, and this was divided by mass 1 plus mass 2. So we can merely now substitute here. We know that mass 2 is 5 multiplied by 9.8 minus 0.3 as a coefficient of kinetic friction multiplied by 2.5 kg multiplied by 9.8 as the gravitational field strength multiplied by cos 30 minus 2.5 multiplied by 9.8 sine 30, all divided by 2.5 plus 5 kg, which gives us actually 49 minus, if we multiply that one, multiply actually cos 30 cos 30 multiplied by 9.8 multiplied by 2.5 multiplied by 0.3, which gives us actually 6.4. So here we get 6.4 minus, say, sine 30, which is 0.5 multiplied by 9.8 multiplied by 2.5, it gives us 12.25. It gives us 12.25, then divided by 7.5. When you add 2.5 kg plus 5 kg, which gives us, actually, we subtract 49 minus 6.4 minus 12.25. Okay, which gives us 30.35 divided by 7.5, and therefore acceleration will be 8.35 divided by 7.5, which gives us actually 4.05 meters per square seconds. So this is the acceleration, and therefore you now calculate the tension. The tension, we can get one of these equations. We can get equation 2, which is the tension is equal to mass 2 times gravitational field strength, mass 2 divided by gravitational field strength minus mass 2 times acceleration, mass 2 times acceleration which gives us actually 5 as the mass 2 is 5 kg multiplied by 9.8 minus 5 multiplied by 4.05 as our acceleration that we got. And this is actually 49. That is, if you multiply 9.8 multiplied by 5 gives us 49. And 4.05 multiplied by 5 gives us 20.25. 20. Gives us 20.25, which gives us actually 49 minus 20.25, which gives us 28.75 newtons as our tension. And so today I thought we can look at how we can use the coefficient of kinetic friction. For those who want more lessons on one-on-one, you can actually contact me on my WhatsApp number, which is +260 977 41 99 49. Remember also to subscribe to my YouTube. Thank you.